You know, the circle exhibits so much structure that sometimes I want to cry tears of joy because it really is such a rich, rich geometrical object. Let me show you one that brings me a tear sometimes, and let's see if I cry in front of you. All right, so here we have a circle, and I have two chords drawn in. I have the chord PQ, and I have the chord RS. And we're told that, in fact, PQ is congruent to RS. We're given that information. And our mission is to figure out what the length of PQ is. How can we possibly do that? Well, notice that we're actually given a little bit of information. We're told what the measure of this arc here is. The measure of this arc, the arc PQ, is given to be 5x degrees. And the measure of the arc RS is given to be 3x plus 40 degrees. The question is, what is this length? Well, how are we possibly going to find it? Actually, what we want to find, I should say, I said the wrong question. I want to find this arc, right? I want to find the measure of this, PQ. So here is our goal. We want to find the measure of PQ. Now, it looks like there's no way to do that. All I know is that this line segment is congruent to this line segment. Well, here's an amazing fact about circles, an amazing theorem, which is that if you have two chords that are congruent, then, in fact, the arcs that they have here are actually going to have the same measure. So, in fact, this measure is equal to that measure. And that's going to be the key to allow us to figure out what x is and then to figure out what PQ is. So let's start. This is so cool. So I know that this measure, which is 5x, has to equal this measure, which is 3x plus 40. I can now solve this algebraic equation for x. If I subtract 3x from both sides, I'll see 2x equals 40. Divide both sides by 2, I see x equals 20. And so I see that the answer is x equals 20. Am I done? Absolutely not. The question was, we want to find the measure of the arc PQ. How do I do that? Well, I know that it equals 5x. And I know that x equals 20. And so therefore I see this has to equal 5 times 20, or 100 degrees. And so this is 100 degrees. And that is the answer. So you can see how we're using these wonderful properties about the symmetry of the circle to say that if I have congruent chords, then the corresponding arcs are actually going to have the exact same measure. Really cool. Let's take a look at another example where you can see even more symmetry. I haven't cried yet, but it's just a matter of time. So here I've got a bunch of circles, and I'm given some information. I want us to analyze all the information and see if we can figure out what's going on. The first thing I know is that the circle centered at A, so the A circle, is congruent to the P circle. What does that mean? Well, that just means that, in fact, the length of this radius is going to be equal to the length of this radius. So that's a fact that we know. And we're also told that the arc BC is congruent to the arc QR. And you can see they're marked. You might not be able to see it too clearly, but there's actually a little teeny mark here to indicate that these are, in fact, congruent. Our mission is to find the measure of angle BAC. So our challenge is to find this angle right here. How can we possibly do that? Well, I know what the angle is. The angle is 11x plus 3. I know what this angle is. This angle is apparently 13x minus 11. That's given to us. The question is, what is the measure of that? How do I do it? Well, since these circles are congruent, and I know that this arc is congruent to that arc, then by the symmetry of the circle, we have a spectacular theorem that tells us that the angles formed are going to be congruent as well. So that means that angle BAC is congruent to angle RPQ. So in fact, these are congruent, which means that their measures are equal. Well, that means I can set this equal to that, and I can solve for x. Here we go. So I have 11x plus 3 equals 13x minus 11. If I subtract 11x from both sides, I see that 3 equals 2x minus 11. If I add 11 to both sides, I see 11, 12, 13, 14. I see 14 equals 2x. And so therefore, if I divide both sides by 2, I see that x is the same thing as 7. So x equals 7. But that's not the answer, because I'm supposed to find this angle, BAC. So I have to go back and plug in 7 here. So I see 11 times 7, which is 77. I add 3, and I get 80. And so I see that's 80 degrees. And that's the answer. By the way, you might want to check a little bit and just verify for yourselves that if you plug in 7 into here, this also is going to yield 80, as it should. So you can see the power of the symmetry of circles, and you can see all the structure that a circle really has once we start to draw in a few lines. I was able to actually share this with you without crying, but that was rare.